Okay, so we're going to change gears from fractions and we're going to move into something called solving simple equations. And these will be 1 and 2 step problems. So that's our goal, and we're going to use something called opposite operations involving adding, subtracting, multiplying, and dividing. Alright, so let's start with 10 equals 10. Is this a true statement? And hopefully I get a resounding yes, this is a true statement. So if we imagine an equal sign being like a scale or balance or teeter-totter, when each side of the equation has the same value, regardless of their appearance, it's considered equal. So this is really important. Lots of people tend to use equal signs like commas or arrows, and that's an incorrect use of them. Okay, so you can only have one balance point on a teeter-totter or a scale. So we have one equal sign per line, and it doesn't matter if the appearance changes. As we'll see shortly, they're still equal. Okay, so are the following true or false? 20 equals 18 plus 2. Does the left side equal the right side? And the answer is yes for this one. It is totally true. Okay. 4 minus 19. Does that equal negative 15? Okay, so if you have to draw a model, you have to come up with different ways, number line, whatever you need. Take a second to think about it. And the answer is yes. This is also true. So even though it doesn't look very familiar or very comfortable, it is also true. All right, 45 divided by 15, does that equal 12 minus 9? So you may have to do a little bit of work here on each side. How many 15s fit into 45? 3 of them. And then 12 minus 9, that's 3. So does 3 equal 3? Yep, this is a true statement. Okay, D, 9 times 8, does that equal 36 times 2? Okay, so 9 times 8 is 72. 36 times 2 is 72. Does 72 equal 72? Absolutely. So this is a true statement. Okay, so it is possible for the left and right side to be equal in magnitude but appear differently. This is one of the fundamental ideas in mathematics that makes it both interesting and frustrating. Okay, so this is a very important concept to understand before we start solving equations. Things can look different but still be equal. Okay, and I'm going to take you through the next few questions here, and you might get really frustrated on these. Stay with me. I'm going to show you a technique by time we're done that will make all of these significantly easier. Okay, so what is the missing value to make the following statement true? 24 equals 12 times something. Okay, and I've put a little dash there for the something. So the missing value that has to go in here would have to be a 2. Okay, 12 times 2 is 24. So pause it for a second, try this one. 34 minus something equals 11. So hit pause. Okay, so now 34 minus something is 11. That would be 23. And again, if you can't get these or can't see them right away, don't panic. I'm going to show you some strategies how we'll get through all of this. Now I have a dash here. Something divided by 12 equals 5. Okay, so we need a bigger number to see how many 12s we get inside of it. I have to total for 5, so that answer here is 60. Now something times negative 6 equals positive 42. Okay, so again, pause it, maybe jot something down, think about it a little bit. Okay, so now the first thing I'm going to notice is that I have a negative 6 here, but my final answer is positive, so I know right away this has to be a negative value. And then if I'm comfortable with my multiplication facts, I know that's a negative 7. Okay, let's try a little bit trickier. Okay, and again, if you can't get them, don't panic. By the time we're done today, we'll make all of this really straightforward. What is the missing value to make the following statements true? So 2, here let's hide this one so we don't go too far. 2 times something plus 9 equals 31. Okay, so pause it, make a guess, do your best. Okay, so let's have a look. So now I have to multiply something by 2 and then add 9 to it. Okay, so I'm going to go with 11 because 2 times 11 is 22. 22 plus 9 gets me to 31. Okay, so these are thinkers. They're not easy. It takes a second to think about them. Okay, so now the next one. 5 times something plus 6 equals negative 14. This is a really tricky problem. So pause it, jot some things down, and then let's see what you get. Okay, you ready? Okay, so I'm going to say the answer is negative 4 because 5 times negative 4 is negative 20. Negative 20 plus 6 is negative 14. Okay, now once again, if you can't see these, that's absolutely okay. These are pretty tough questions. By the time we're done today, though, you'll be able to solve these with no problems. Okay, so a blank or a dash is not the best way to represent things. So we tend to use letters, which we call variables, or unknowns, doesn't really matter. Variables is probably more common. You can use any letter you want instead of the dash. Sometimes we use boxes in early grades to show that something's missing. In high school, we tend to use letters like A or N or X. So this question here is something plus 12 is 22. In high school, we tend to write it A plus 12 equals 22, or N plus 12 equals 22, or X plus 12 equals 22. The letter doesn't matter. It's just a symbol to represent a container for holding some number. Okay, if you really wanted to, you could do this. Smiley face plus 12 equals 22. Okay, it's just a symbol that shows we don't know that value yet. Okay, all right. Now here's a big idea. This is the main focus of today, and if you can get this early, it makes everything easier. We already agreed that 10 equals 10 is a true statement. If I add 2 to both sides, have I maintained my equality? So this would be 12 equals 12. Am I still equal? Yes, I am. Okay, now I'm going to subtract 4 from both sides. So 12 minus 4, that becomes 8. Am I still equal? Absolutely. Okay, I'm going to multiply both sides by 2. Am I still equal? Absolutely. Okay, and then just for kicks to make sure we're being fair to all of our operations, the last one would be, can I divide both sides by 4? And if I do, I get 4 equals 4. The statement is still true. So as long as I do the exact same operation on both sides of the equation, that's the key. I did the same operation on both sides of the equation. I maintain my equality. That's really, really important. Okay, so when we're solving an equation, okay, so to determine the value of the variable, we can use our 4 main mathematical operations. So all we're going to use is add, subtract, multiply, and divide. The goal is what we call isolate the variable. Okay, so that unknown letter, that piece we're looking for, we want to try and get it by itself in the top location and have a coefficient or a number in front of 1. Or sometimes we don't even write it. Okay, so all we're going to be doing is adding, subtracting, multiplying, and dividing to solve these problems. So I'm going to start with a picture, and then we'll tie in the algebra, and you'll see hopefully how easy this is. So we have n plus 3 equals 7. So this box right here, this is my n. It's my unknown amount. Plus 3 equals 7. So if I take a couple of zero pairs here, so if I introduce 3 negatives to this side and 3 negatives to this side, then these guys all zero out. These guys zero out. And then this unknown amount in n must be whatever's left over. So in this case, n should be equal to 4. Now what that looks like from an algebra side or writing the actual equation side, we have n plus 3 equals 7. So if I introduce this negative 3, or subtracting of 3 on both sides. Those cancel. I'm left with an n isolated by itself on the left-hand side, and then all I have to do is 7 minus 3 on the right-hand side, and I get the same answer. Okay, so let's do one or two more here. I have n minus 6 equals 3. So again, the box represents n, the unknown amount. I have 6 negative tiles here and 3 positive tiles on this side. If I want to cancel the 6 positives, the 6 negatives, I need 6 positives to do that. And you can probably see where the opposite operations in this conversation is going to come from. Okay, so these guys right here, these 6 negatives and these 6 positives all zero themselves out, so they're gone. Okay, so this n must be equal to 9. Okay, so from an algebra standpoint, what that looks like, we introduced 6 positives, so we added 6 to both sides. These would cancel, and we're left with n equals 3 plus 6, or 9. Okay, so now we're almost through our operations. 2n equals 12. Well, 2n means I have 2 boxes that I don't know. I have 12 chips over here. Okay, so this one's a little bit different. Okay, so I want to break up my my group of 12 here into 2 separate groups. Okay, because these n values both have to be exactly the same because it's the same unknown. So this guy and this guy must have the same amount. So in this case, n equals 6. If we were looking up here at the actual algebra expressions, the opposite of multiplying by 2 is dividing by 2, and then these 2's would cancel, and n would equal 12 divided by 2, or 6. Okay, this one's tricky. This model is a little different for division. So I have n divided by 3 equals 4. So we're looking for how many of groups of 3 fit into the unknown number. And we know that's 4. So I know there are 4 groups of 3 that fit into this unknown number. And if we count all of those up, we would see the answer is 12. Okay, so if I come over here, the opposite operation of dividing by 3 is multiplying both sides by 3. This 3 and this 3 cancel. N equals 4 times 3. N equals 12. Okay, and again, you may have to go back and rewatch these again just to sort of make sure you have it down comfortably. Here's the key idea. To undo an adding operation, we need to use subtracting. To undo a multiplication operation, we need to use a division. This is called inverse or opposite operations, and we use this to solve problems. So here's what they look like. The first thing you have to do is identify the operation that you want to cancel out, and then do the opposite of it. So in the first one, we have n minus 15 equals 32. So the operation we're looking at is the minus 15. So the opposite of subtracting 15 is adding 15. So if we add 15 to both sides, they cancel on the left side. Our n is isolated by itself on the left-hand side, and then we just have to add 32 and 15 together for 47. Okay, let's move on to B. This one right here, this is 6n equals 18, so that's 6 times n, or multiplication. The opposite of multiplying by 6 is dividing by 6. And please try and write this the way I'm showing you. Over years and years that I've done this, I've found that if you write it a certain way, it really makes it easier to see the solutions. Those 6's cancel, and you're left with n equals 18 divided by 6, or 3. Okay, we're almost there. X plus 33 equals negative 4. So the opposite operation of adding 33 is to subtract 33 from both sides. Those would cancel. The unknown x is now equal to negative 4 minus 33, and this is why we started with integer adding and subtracting this year, because we need to be able to work with these negative values. This is negative 37. And now lastly, m divided by 14 equals 5. I don't like the way that's written. I prefer writing my division like this. And now the opposite of dividing by 14 is multiplying both sides by 14. That 14 on the top cancels with the one on the bottom for 1. It leaves me with m equals 5 times 14, or 70. Okay, those are all one-step problems, and we're just using opposite operations. Okay, so now you might recognize this. We use something called SAMDEB, which is bed mass backwards. We use it as a guide. Okay, it's not a rule, it's not a law, it's just a guide. So when we're not sure how to solve, we can use SAMDEB as our guide. Okay, so reminder, isolate the variable means get it by itself in the top location with no other numbers around it. And we're going to do all of that with just adding, subtracting, multiplying, and dividing. Okay, so I'm going to do one more, I think, with a picture here. If I can get it to move down. Yeah, and then we'll just try a couple more. So now this is a two-step problem, and I'm going to work with my SAMDEB as my guide. So 2n minus 8 equals 10. So I have two of these unknown boxes. I have my negative 8 or minus 8 there represented, and I have positive 10 on the right-hand side. So the first thing I want to do is get rid of, see the s and the a there to start. I want to go after subtractings and addings first. Well, I have a subtracting of negative 8 there, so I want to add 8 to both sides. So I'm going to introduce, try and do this as quick as I can, 8 positives to both sides, which is how I represent adding 8. Okay, so there's 8 added to both sides. That means all of these guys here would cancel each other out and be gone. Okay, so now I'm left with 2n. When we go back to our algebraic expression, the opposite of subtracting 8 is adding 8. So if I add 8 to both sides, those cancel. I'm left with 2n equals 18. And if you look over here, I have 18 chips on the right-hand side. Now I want to try and figure out what goes in each box. So I'm going to grab this box and separate it here. Okay, that's an act of dividing. So I'm going to try and split these up so that I have, equal amounts. So that's close, but I need to steal one more down here. Okay, so now both of these boxes have 9 chips in them. The opposite operation of multiplying by 2 is dividing both sides by 2, and we are left with n equals 9, which is how much we have right here. Okay, so now we can't draw the pictures all the time. Some questions just won't be very friendly for that. So we're going to start practicing without it. So again, SAMDEB is our guide for solving. So we have 2a plus 16 equals 38. We have a multiplication operation and an adding operation. Well, the adding operation has to come first before the multiplication operation. So what is the opposite of adding 16? Well, subtracting 16. So these cancel, and we're left with 2a equals 38 minus 16, which is 22. Now over here I have the multiplication operation of multiplying by 2. So I'm going to divide both sides by 2, and I finish with a equals 11. Okay, now if you wanted to, you could do a check. And I won't do that here too often just because it takes up too much time from the video side of things. You take your original expression and you insert or substitute the value you found, in this case 11, and then you check to see if the left side and the right side balance. So 2 times 11 is 22, plus 16 is 38. Those two balance. I know I am correct. Okay, so take a pause here and try this yourself. Again, SAMDEB is our guide. So in this problem, I see both a multiplication and an addition. So I want to do the addition first before I do the multiplication. So what is the opposite of adding 22? I subtract 22. And please get in the habit of writing that down. It makes a huge difference. These guys cancel, and then I rewrite my next line. And you'll notice a couple of things. I try and write terms right below each other. I try and line my equal signs up. It helps keep track of where all of the values are going. 10 minus 22 is negative 12. Now, a lot of people will mistake this one here. This is not a subtracting of 4 on the A. This is a multiplication of negative 4 onto the A. So the opposite of multiplying by negative 4 is dividing by negative 4. Okay, and again, this is why we reviewed all of that integer stuff with adding and subtracting, multiplying, dividing, because it all shows up in our equations. Okay, so now these 4's cancel for 1. We're left with A equals. Now, a negative 12 divided by a negative 4. Two negatives are going to leave me with a positive result. 12 divided by 4 is 3. So the final answer here is 3. Okay, we got 2 more to go. So if you want to pause it, try this one. We have a dividing part here and a subtracting part. So the subtracting is going to come before the division. So I need to know what is the opposite of subtracting 12. And you yell out adding 12, and you would be absolutely correct. So we leave this alone, A divided by 2. These guys cancel. 30 plus 12 is 42. Okay, and now I have a dividing by 2 as my last operation to deal with. So I'm going to multiply both sides by 2. Please note where I write that 2. I did not write it down here. I wrote it at the top location. That's really important. Okay, I don't want to put it in the middle. I want to make sure I know what's in the top, because these guys will cancel for 1. And you're left with A equals 42 times 2, or 84. All right, last one. Pause it and give it a whirl. Okay, so in this one, it looks a little complicated, but there's really only one operation. There's just a dividing by 6. That's the only operation I have to deal with. Okay, so the opposite of dividing by 6 is multiplying both sides by 6. So these cancel, and we're left with A equals. Now, you may want to put a placeholder here. And now we have a fraction problem where we're multiplying two fractions together. So if we have to, let's go over to the side and just think this through for a minute. Now we can multiply across the top and across the bottom if we like. We could also do something a little different and look at this piece right here. Okay, 6 over 24, that could be reduced first. You've got lots of options. I'll go across the top first just to make sure everyone can follow along. So I would have 96 on top, 24 on the bottom. Okay, and then if you want to count 24s, if you're comfortable, 24 and another 24 is 48. Another 24 is 72, and then one more 24 is 96. You could also use your calculator on it. That's a good place to use your calculator. Either way, the answer is 4. Okay, so that was a bit of a long one. That's should be a little bit new for some, but hopefully it's review for most. You have a task to try for solving. Thanks for tuning in.